Okay, so we're looking at bits and bytes. Does anyone have a clue what a bit is? It's something about little, electrical stuff, yes? We're on the right track with electrical stuff. Something electrical. Okay, we're looking at
storage.
Yes. Electrical storage, memory, yes. Okay. When we're looking at storing data, it is stored in a bunch of zeros and ones. Does everyone know that? Yeah. Okay, so if I wanted to store the letter F, I couldn't, the computer doesn't know the letter F. It just knows zeros and ones, okay? It cannot recognize our alphabet or an exclamation mark or a question mark. It just records zeros and ones. Every little zero or a one is called a bit. Okay, so it's the smallest unit of memory. Okay, so a bit is the smallest unit. We're just saying on a computer, but it's on your phone, on anything. Okay, so all electronic devices, the smallest unit of memory is 1 bit. Okay, it's a 0 or a 1. Okay, now the abbreviation for bit would be the lowercase b. Okay, just like the abbreviation for meters is a lowercase m. Okay, so the abbreviation for bit is a lowercase b. Now, bits have the same conversion rate as we are used to in the metric system. Okay, so if I wanted to know what a kilobit would be, what would it be?
1,000 bits.
It would be 1,000 bits. So the conversions follow our same pattern as we do for the metric system. Okay, so conversions, they're the same as the metric system. Okay, so we know that 1 kilobit would be 1,000 bits. Does that make sense? Okay, what comes after kilo?
Mega.
Mega. And what letter do we use for mega?
MB.
A capital M. Excellent. Okay, so a megabit, this is a kilobit. 1 megabit. So we're looking at kilo, mega. 1 megabit, what's that going to be? It's going to be 1,000 kilobits or 1,000,000 bits, okay? So it will be 1,000 kilobits, exactly the same as we would do for any other metric, which is 1,000,000 bits. What comes after mega?
Giga.
Giga. What letter do we use for giga?
G.
A capital G or a lowercase?
Lowercase.
Capital G. Okay, so 1 gigabit would be
1,000 megabits.
1,000 megabits. Okay, what comes after giga?
Tera.
Tera.
I don't know.
Okay, so 1 terabit would be 1,000 gigabits.
Gig.
Okay, does that make sense?
Yeah.
Now remember, a bit is a very, very small piece of information. It's just a 0 or 1. Yep. Yep. That's 1,000 gigabits. Cool, so everyone got that?
Yeah.
Oh, you have some name, that's what you said.
So we've got kilo, mega, giga, tera. We're stopping there. Okay. Now, as I said, instead, your computer records every symbol as a small string of bits. Okay, so every letter, every symbol, a question mark, a full stop, every symbol is represented by a group of bits. Because clearly bits are not a lot of information. You can only store two different things, a 0 or a 1. So that's not particularly useful. So it stores these bits in little groups called
Bytes.
bytes. Bytes. Okay. So a byte, okay, equals 8 bits. Okay. Shh. Okay, so your computer, your phone, guys, everything in the cloud, all our little pieces of information all come down to a string of zeros and ones. Every symbol is represented by 8 bits, okay? So, what do you say? So it's, for example, guys, Oliver. Now it gets really confusing, okay? So, just to be really tricky, how many kilobytes do you think are in a byte?
Oh, like 1,000.
It would make a sense to be 1,000, wouldn't it?
But it's something.
Unfortunately, it's not, okay? So just to be really tricky, it is 2 to the power of 10, which is 1,024. Okay, because it's a binary system, so it works in just zeros and ones, so it's not base 10. So we're just going to be really tricky. So if I wanted to have 1 kilobyte, okay, 1 kilobyte is not 1,000 bytes. Okay, it's 2 to the power of 10, which equals 1,024 bytes.
Why is it 2 to the power of 10?
Okay, we're using base 2 because there's 2, 0 or 1. We've got 2 options for everything.
Right?
It's like
Okay.
2,
Yeah.
4,
But Miss 2 to the power of 10,
16,
is it
32.
1,024.
is it actually?
Yeah, it is.
So if I actually did.
You actually grab a calculator, type 2 to the power of 10,
It just
it will be
doesn't sound right.
1,024. But it is right. Promise.
I know, right? Where does 1,000 come from?
Okay, you can type it in, trust me.
No, Miss, I believe you. It's okay.
It does actually work. Okay, so if I was going to go from kilobytes, what was after kilo?
Tera.
Wait, what?
Mega.
Mega.
1 megabyte.
Oh no, like cloudy.
Okay, 1 megabyte is going to be how many kilobytes? 2 to the power of 10 kilobytes. What will that be and how many bytes would it be?
I need a bite of pizza right now.
It's 1,024 kilobytes, yes? But what do you think it would be back in bytes?
Not kilo, but is it kilo?
It's kilo. Yeah, it is.
I don't know.
There you go, learned some English today. So it's 2 to the power of 10. Right? 2 to the power of 10 kilobytes.
What about Eamon's maths?
He was right, you were
I
wrong.
know, it was fun.
What's 2 to the power of 10 times 2 to the power of 10?
Just take that out of context.
What's 1,020?
2 to the power of 20. 2 to the power of 20 bytes. Alright, now I'm getting a bit sick of writing bytes, so I need an abbreviation. What do you think the abbreviation for bytes is?
Capital B.
Capital B. Okay, so the abbreviation is capital B. It's a very dodgy looking 20. Okay, 2 to the power of 20 bytes. Or 1,024 kilobytes. What came after mega?
Giga.
Tera. Tera. That sounds scary.
Tera sounds scary, does it? So 1 gigabyte is 2 to the power of 10 megabytes. And what was the last one, Sarah?
This, we don't need to memorize all of this, do we?
I'm about to give you some really good news.
So we don't. It's on the formula sheet. That's just brilliant.
Alright, so on your formula sheet, it looks exactly like this. Quiet. Year 11. Shh. Okay, on your formula sheet, they tell you this. That 1 byte is 8 bits. They also give you these conversions. Okay? They don't give you these ones back here. Why don't they give you these ones?
It's just a given.
Because they're the ones we've always been doing. We've always been doing 1,000 kilo. That's our normal.
Did I tell you what a bit is, though?
Yes, they tell you this. Okay? So on your formula sheet, you have a look at the bottom of page 3, Tim. Bottom of page 3, you will see that 1 byte is 8 bits and it gives you these conversions. So you do not have to memorize them. They are there for you. Alright, let's practice using these conversions. Okay, let's try and convert. Alright, let's do 256 kilobytes into bits. It's a bit tricky. So, okay, so I've done a capital B, Oliver. So that means it's kilobytes. Okay, and I want to go all the way to bits. So from kilobytes, I need to go to bytes first, and then from bytes, I'm going to go to bits. So from kilobytes, I know that from kilobytes to go to bytes is 1024. So I'm going to take my 256, I'm going to times by 1024, and that will give me how many bytes I have. So it's 256 times 1024, you're right, Steph? So I've got 262,144 bytes. Okay, which is capital B. Now I want to convert that to bits. So what do I do now? I know how many bytes there are. How do I convert that to bits? Times by 8, because there are 8 bits in a byte. So timesing that by 8. So I get 2,052,000. Bits. Note that I've changed to a lowercase b because it's bits. Okay? Does that make sense to everyone? So I've started at kilobytes, I've converted it to bits, converted it to bytes, and I've converted it to bits. I could then, let's say I wanted to convert that to,
The end result is bytes.
this is bits. I started at kilobytes, capital B, and now I'm in bits.
Okay, gotcha.
So how many little tiny zeros and ones there are? There is 2,097,152 little zeros and ones. Okay? What if I wanted to convert that into kilobits?
That's very, very a lot for numbers. For numbers, because if you think about when like megabytes is small to us.
Yep. And that's just kilobytes.
Wow.
Okay? So you know, you're getting a
Is
feel for how
kilobytes
big.
smaller
Yes.
than megabytes?
Yes.
That's
Makes
megabytes
sense.
is bigger.
Yes.
So what's that byte thing down there?
Bits.
That's the smallest.
A bit is the smallest. Remember, a bit is a 0 or
And
a
then
1.
it goes mega. No.
No.
Okay.
What we've done is we've started at kilobytes and we've converted it to how many zeros and ones there are. Okay?
Okay.
So, I don't know.
So what's the question?
Am I doing your head in, am I?
No, I
Yeah.
get it. What's the
Okay, so I've started at kilobytes.
Yeah.
So 256 kilobytes. This might be a file you have.
Like kilobits?
No, that's kilobytes. Okay? Because
There's a
generally when we
difference.
talk about data, we don't talk about bits at all, do we?
I get it.
Okay?
Yeah, I get it.
When we talk about data, you say how big a file is, everyone talks in bytes. Okay? That's how we talk about data. What we've done here is converted what the file size was in bytes to how many little tiny bits that was. Okay? Alright, we do one more example.
But that won't be like common, will it? Like bits to bytes, bytes to bits. We're not just staying in bytes, right?
Yep. Okay, but we're trying to understand how it works. Alright, let's try and convert. Alright, let's do one more conversion. Let's say we've got 500 megabytes. We start with 500 megabytes. We're going to convert it to, I want it to bytes and to bits. So we're going to go from megabytes to bytes. We're also going to convert it to bits, and then we might go to kilobits as well.
Don't you times by a million to get to bytes?
Okay, so let's go from megabytes to bytes.
It's pretty sure it's a million, right?
How do you go to mega?
Oh, I like it.
Okay, you're thinking metric. But remember, bytes do not work on the metric system.
Oh my goodness.
Bytes are binary.
2 to the power of 20.
1024 is our key number now. This is your key number.
What? But to get to bytes, not kilobytes.
Okay, we are on megabytes. From megabytes, back here, we're starting at megabytes, which is here. We're going to have to go from megabytes to kilobytes, which is 1024. Then we're going to have to go from kilobytes to bytes, which is another 1024. Okay?
Wait, do you divide it?
Times.
1024.
Because, same rule as always converting. So if you were going from meters to centimeters, they're smaller, so there's more of them, so you times. So if we're going from megabytes to bytes, they're smaller, so there's more of them, so it's times.
So is it 1
Yes,
million and 40?
got it.
So there's such a thing as just bytes, like,
Yes.
okay, so I didn't get that part.
So each byte is how many units of symbols
So it
there are.
goes like bytes, megabytes.
Bytes, kilobytes, megabytes, gigabytes, terabytes. And if you forget the order, it's on your formula sheet. Okay?
How many bits in a byte?
8 bits in a byte.
8 bits in a byte.
So would it be times by 1 million and 48?
Okay.
40
No.
something then? What?
It's a lot easier to say times by 1024
Times 2?
twice squared.
Is it the same as timesing by 2?
No, timesing by 2 would be timesing by 2048,
True, we
which
don't want
is
that.
very different.
I love that
We
game.
don't want that.
Timesing by 1024 times by 1024 again. Why did I have to do it twice?
Yeah.
Because you're changing it to megabytes.
From
Yeah,
mega
so it's 1 million
to
and
kilo.
48.
We got it?
It's 1 million and 48. Okay.
I wrote yes, that would be meters, wouldn't it?
Where's the bits coming?
We're not up to bits yet, we're just doing bytes. You're all looking very grumpy at me.
Why would they throw this as a test?
Alright, stop being grumpy with me. I'm trying to explain it. Shh. Okay, quiet. Shh. Let's finish this example. Mackenzie.
It's 1,048,576 times 500.
Okay. Shh. That's how many bytes I have. How do I convert that to bits? Times it by 8. Answer times 8.
Yes, we don't need
Yes, there's always 8 bits in a byte. Okay? And you get an even bigger number. Okay, let's not convert it to kilobits. Let's go to gigabits. Alright, let's go to gigabits. Now we know there is some massive number of bits. Okay, this was our bytes, this is our bits. Huge number of bits. We're going to convert to gigabits. Now, how many jumps is it from bits to gigabits? Tongue twister. So we got bits. We're going to kilo,
mega,
mega,
Giga.
giga. 3 jumps. So I'm going
To the power
to
of 3.
divide by 1,000.
To the power of 30.
Yeah.
So there's 1,000 between each.
For bits. For bits it's always 1,000.
You know, you can't just whip out the 1,000 now. What happened to the 1,024?
Ah, because these are bits.
Oh,
Bits
okay.
are 1,000.
I don't know what's bits.
Bytes are 1,024. So little b,
Yeah.
bits. So you've got to get clear in your head. Little b is normal, 1,000. Capital B is bytes, which is 1,024. We're getting there?
That's tricky.
Okay, so if I divide by 1,000 cubed, I get to 1 decimal place 4.2 gigabits. Okay, did we cope with that? No. Not at all. All right,
Let's
let's try some questions.
Oh,